Hey guys, welcome back again to Math 100. Today we are doing section 12.3, the fundamental counting principle. Okay, guys, so FCP we call it for short, and this one to me I think is the easiest actually of the three. It's the most direct. In fact, we've already used it in the background when we were coming up with or when we were discovering the permutation or combination formulas. And it says simply, if you have a task A that can be done in m ways, let's use different colors for this. Task A that can be done doing task. Sorry guys, I cannot speak. Task A that can be performed in m ways, and task B that can be performed in n ways. Then task A followed by task B can be performed in, and you probably guessed this, but m times n ways. And so today's lesson, today's counting principle boils down to something very simple, and that is you just multiply. You multiply them together. So you take the numbers you got and multiply them. Now, in practice, it's going to look a little more complicated that when we have particular situations you got to decipher. But at the core of it, that's all it is. You just multiply. Now, if you think carefully about this, really, I think it makes the most sense, most intuitive sense, where we get this fundamental counting principle. And that's it. That's pretty much the whole theory for today. But what's going to be challenging, kind of similar to the last chapter, chapter 11, is deciding which counting principle we want to use. And so at the end of class today, we're going to have a bunch of questions where you have to decide which counting principle should you apply. But to start, let's look at this first question, examples for the fundamental counting principle, or the FCP. Okay, so question 1. You have 3 pairs of pants, 4 shirts. How many total combinations of pants and shirts are possible? Okay, be careful, guys, because you might have noticed this word combination. It's just because you see the word combination, that doesn't mean that we're going to use the combination technique. So think about what is happening in the situation. We're not choosing a smaller group from a large group, because that's what we mean when we say NCR, right? The combination formula. In this case, we have 3 pairs of pants and we got 4 shirts. And we want to know how many ways can we combine those two things. And so here's a picture for what's happening. And this picture is really kind of like the fundamental picture of the fundamental counting principle. It's like the 기본특기나, or what's the English for that? The typical example of this counting principle. For some reason, they always like to start with like clothes, because I think that's kind of like an obvious place to start. Okay, so anyways, you got 3 pairs of pants. Let's say you have a pair of black pants, and you got a pair of white pants. Oh, look at you wearing white pants. Okay, and then you got a pair of red pants, and you got your red pants are these red shorts. All right, so you have 3 pairs of pants, and you have, for each of them, you can choose any of the 4 shirts. Okay, so let's say that first black pants, I got 4 shirt options. Okay, I'm gonna spend way too much time drawing these shirts right now, but I'm just only gonna do once, okay? And I didn't give myself enough space to draw my shirts. Okay, getting lazier and pictures deteriorating, but you get the idea. Okay, so 4 different shirts. First one, maybe the black shirt. Again, black shirt, black pants. A white shirt, maybe one shirt with red stripes. And then a green shirt. Okay, so you got all these options, right? Black pants with any of those 4 shirts. And then you could repeat the same thing with the white pants. You have 4 new options. And then with the red pants. Let me just rearrange these guys. Oops. Give myself some more space here, guys. Sorry, this is like so painful for you to watch, probably, because it's taking so long. But here we go. Okay, so I'm not gonna bother drawing them again, but just suffice to show like these lines indicating a different option, right? So option 1, 2, 3, 4. Option 1, 2, 3, 4. And so you ask yourself, okay, how many options do I have altogether? Well, for each of the 3 pairs of pants, you had 4 different shirts, right? So how do you solve it? You just take 3 and multiply by 4. And if you think about it, this is one of the ways you may have learned to do multiplication, or like in kind of like a visual or picture how you learn to do multiplication back in elementary school, right? This is like a typical kind of story problem that you'd be given. And so that's all it is. That's the fundamental counting principle. Now I could add another element to this. I could add like shoes, right? And then if I add those 3 things, I'd have, okay, pants, shirts, and then shoes. And then for each shoe, that would branch off again, right? So what you end up with is this kind of tree diagram. And then what you're counting is you're counting how many branches you have at the very end. And that will tell you, determine how many total outcomes are possible. And how do you count them? You just multiply, right? Let's say I had 5 shoes, then I'd take 3 times 4 times 5. That's the whole principle. So super easy, right? Okay. Answer to this question, 3 times 4 is 12. Excuse me, sorry. Okay, so question number 1. 3 times 4 equals 12. 12 is your answer. Question 2. You have 5 pairs of pants, 5 pairs of pants, 10 shirts, 3 different pairs of shoes. This is what I was just talking about a moment ago. What do you do? Multiply, right? 5 times 10 times 3. 5 times 10 is 50, times 3 is 150. So there you go. Okay, how many 4-digit iPhone passcodes are possible? Right before I tell you the answer, think about it for a second, see if you can try it on your own. Okay, and I'm assuming you've tried it. Here's the answer. So do you remember permutations? We did something like this where you had the blanks, right? And we say, okay, first position, I got so many possible answers. And when we did permutations, we kind of counted down. But here, with an iPhone passcode, you got 10 options for the first digit. Why 10? Well, because you have 0 through 9, right? If you count that's 1 through 9 is 9 digits plus the 0, that's 10 total digits, 10 options. Now in the second number, this time I'm allowed to repeat digits again, right? So even if I chose 0 the first time, I could choose 0 again, which means in my next space, I have another 10 options, and then another 10 options, and then another 10 options. So it's 10 times 10 times 10 times 10, or 10 to the 4th if you like. So a condensed way of saying the same thing, or the answer is 10,000, right? Because that's 4 zeros. When you multiply tens and you just count the zeros, right? So it's 4 zeros makes 10,000. So there's 10,000 possible iPhone passcodes. Note, guys, remember back to permutations and combinations. We had that one definition that to start with. We said that to make it a permutation or combination, you cannot have repetitions, which differs from the FCP, right? The FCP, you are allowed to have repetitions. You can have a passcode of 11111 or 00000. Or you could have something like 1200, where you have just 2 zeros. Okay, number 4. Okay, I'm sorry. Before we go to number 4, note here, it says, the remaining questions may or may not use the fundamental counting principle. So now that we've learned the fundamental counting principle, we're going to practice how to figure out when to use it. They also might involve permutations or combinations. So be on the lookout for any of these 3 counting principles. Often when you counting problem, half the problem is figuring out which formula makes sense to use. Sometimes none of the formulas we learned applies. Although I think every problem I have here, it applies in some way. Sometimes you can also have combinations of more than one counting principle. Like you could have a permutation question that also uses the FCP or something like that. All right, guys, what I'm going to do is I'm going to cut this video off. This is like sort of the introduction video where we learned what the FCP was. We saw a few examples. And now in the next video, we'll tackle the remaining problems.